In this video, I will show you how to take this very complex piecewise function and I'll take this graph and we'll write the piecewise function for it, the actual equation. And then we'll answer several questions about it, including things like domain and range. And then I will show you how to do a transformation of it based on this function. But first we need to write the piecewise function. Okay, now this piece of the piecewise function I can tell is a branch of the parent function 1 over x. Alright, so the parent function 1 over x has a horizontal asymptote that is the x-axis. The vertical asymptote is the y-axis. So here I see that this horizontal asymptote is no longer the x-axis. The horizontal asymptote appears to have moved down 1 unit. Alright, so this is a transformation of down 1. So that's why I'm going to write 1 over x, but then I'm going to put minus 1 in order to shift the graph down 1. Now I need to do the domain. Now on my last video I used interval notation. So in this video I'm going to use inequalities. So the domain of this piece of the piecewise function is the x values are less than 0. Okay, the entire graph is to the left of the y-axis. The y-axis is an asymptote. It never touches, so that's why I'm not saying or equal to. So that's it for the first piece. Now the second piece of the piecewise function is a parabola. Normally the vertex would be at 0, 0. Here it is at 2. So the parent function is x squared. But because this is shifted to the right by 2, for this piece I'm going to say x minus 2 squared. Alright, this is what it looks like when you shift something to the right by 2. Now I need the domain. The parabola goes from an x value of 0 to an x value of 4. 0 to 4. Okay, so I'm going to say 0 is less than x, which is less than or equal to 4. Now, whoops, I put the less than and the or equal to on the wrong things. This is a closed circle, so that'll be or equal to 0. This is an open circle, so it will not have the or equal to. So I did that backwards for a quick second. So that's the second piece. The third piece is linear. The parent function for a line is just x. Y equals x. F of x equals x. It's just x. So since that is the parent function, I need to ask myself what transformation happened. So let me compare this to what the parent function would have looked like. So the line y equals x would start at 0, 0, and it would go up 1 over 1 like this. Okay, so let me compare these points to the points I actually have, which are these points. Like, here are 2 points I can use for comparison. So the original point, for example, is here at 4, and this point, the corresponding point, is at 2. Okay, this point, for example, is at 6, and the corresponding point is at 3. So what's happening? Each point is half the value that it used to be. 4 becomes 2, 6 becomes 3. All right, 8 becomes 4. So everything is 1/2 its original value. So what I'm going to do when I write this piece of the function is I'm going to take x but it's being vertically compressed by a factor of 1/2. So I'm going to put a 1/2 in front of it. Now for the domain. These x values are greater than or equal to 4. So I'm going to say x is greater than or equal to 4. So there's the piecewise function. Now, what's the domain of the function as a whole? I'm scanning across looking for any missing x values. There are none. The domain of the function as a whole goes from negative infinity to positive infinity. Even the asymptote, because of this closed circle, we have a point that has an x value of 0. So every x value is included. So the domain is going to be negative infinity to positive infinity. Okay, the range will not be negative infinity to positive infinity. All right, so let's check that out. Because we're doing the range, I'm going to highlight the y-axis. So the first branch has a range from negative infinity to -1. The second piece of the piecewise function has a range of 0 to 4. Notice the arrow. The third piece has a range of 2 to infinity. It goes up forever. So 2 to infinity. And it's okay that it overlaps like that. But as you can see, there's a gap in the y values. There are no y values between -1 and 0. So we will have to write our range in two separate pieces connected by the union symbol. So the lower part of the range is from negative infinity to -1. I'm going to use parentheses, not a bracket, because at -1 there's an asymptote here. Nothing ever touches -1. And then the second part of the range goes from 0 to infinity. This will have a bracket on the 0 because the parabola touches 0. So 0 to infinity. So there's the range of the function. Okay, now we are going to talk about the intervals where the function is increasing. Okay, so when you're talking about increasing and decreasing, you are reading the graph from left to right. So let me highlight to make this clear. As I move from left to right, all right, so I'm starting out on the left. I am decreasing, decreasing, decreasing. I'm falling, 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 falling. Okay, and then suddenly I jump to here, and I'm once again falling until I get to here. All right, but then I start increasing, 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 increasing. And then I jump to here, and then I'm increasing again. Okay, so everywhere that I just highlighted in pink is decreasing. Everywhere I highlighted in green is increasing. So, what are we doing first? Increasing. So basically, look at the green and tell me the domain of the increasing part. What's the domain of the green part of this graph? Well, it's increasing from 2 to infinity. All right, if I look at the x-axis, it's increasing from 2 to infinity. All right, always use round parentheses when you're talking about increasing and decreasing. All right, don't include the endpoints. Now, give the intervals where f of x is decreasing. So what is the domain of the red part, the decreasing part? That's going to be negative infinity to 2. All right, negative infinity to 2. All right, give the points of discontinuity. All right, so there's a break in the graph here at 0. See the asymptote? That's called an infinite discontinuity. All right, so we have an infinite discontinuity at x equals 0. And then we have another break in the graph at 4. This is a jump discontinuity. Okay, and now we need to do some transformations. Based on what we have here, we're supposed to take the parent function f of x and do these two transformations. This negative inside the function is a reflection over the y-axis. Okay, this is going to affect the x values. Anything happening inside the function is going to change the x values. Now this plus 2 that we see out here, this is a shift of up 2. Okay, so this is going to affect the y values. Anything happening outside the function is going to affect the y values. So I like to start off by having some key points to plot, and then I will do the transformation. Okay, so let me erase this highlighting and pick my key values. Well, let's see. So first of all, let me erase this for a second. All right, so I'm going to do my new function in blue. What is going to happen to my asymptotes? Okay, right now I have a vertical asymptote at the y-axis, but I also have a horizontal asymptote that's here at -1. All right, I'm going to color it red to match the original graph. Okay, what will happen to these asymptotes? So what are my transformations again? I'm doing a reflection over the y-axis. Okay, so that's not going to affect my asymptotes. But I'm going to shift everything up 2. Okay, that is going to affect my horizontal asymptote. Okay, so if I shift everything up 2, my new horizontal asymptote is going to be here. So just keep that in mind. This will be my new horizontal asymptote when it comes to this branch right here. So anyway, let's get back to some critical values. Okay, this graph has a critical value at this point right here is a critical value. And then I will do this point, and I think I will do this point, and 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 this point. All right, those are the points I'm going to use for my transformation. All right, so here's a list of those critical values that I just mentioned. So now it's time to do my transformations. As I said before, the shift of up 2 is going to affect my y values. So I'm going to make a new y column, and because I'm shifting everything up 2, I'll make the new y column by doing y plus 2. So my new y values will be 0, 6, 3, 2, 3, 6, 4, 5. So these are my new y values. All right, I'm also going to have new x values because I already remember that we do have a change coming to the x values. Now, what is that change? Okay, a reflection over the y-axis. This negative sign is going to affect my x values. So, I'm just going to do negative x. All right, just the opposite of all my x values. So that'll be 1, 0, negative 1, negative 2, negative 3, negative 4, negative 4, negative 6. All right, so now let me just erase all of these extra weird points that I highlighted and do my graph. Okay, so now I'm just looking at my new x's and my new y's. So I'm going to have a point at 1, 0. Okay, so 1, 0 is right here. Okay, this point used to be this point showing us where the branch is curving. So I already know that this is going to approach the asymptotes on either side, all right, because this is really the only point that we had from this piece of the piecewise function. So it's got to approach these asymptotes, something like that. All right, the next few points are from the parabola. So I've got 0, 6, that's going to be right here. Then I've got negative 1, 3. Okay, so I've got negative 1, 3. And negative 2, 2. And negative 3, 3. And finally, negative 4, 6. And that one should be an open circle. All right. Remember, there's a reflection over the y-axis, so everything is backwards. So there's my closed circle, and now here's my open circle. So I can see very well where my parabola is sitting. It's sitting right here. Okay, and last I have the linear piece, which starts at negative 4, 4, and then negative 6, 5 is right here. So the linear portion of this graph is going to go like this. All right, and again, notice how everything is going the opposite direction of the way it used to go, and everything has been shifted up 2 units. So the blue is the transformed piecewise function. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.